Thank you for joining me for this talk, which is called Hexagonal Modules, a cleaner approach to monolithic API design. So I know the title might seem a bit fancy, but what we'll be truly talking about today are two interesting architectural designs, which are the modular monolith and the hexagonal architecture. We'll see why applied together, they can help us build cleaner, more maintainable monolithic APIs. So my name is Adil. I live in Casablanca, Morocco, and I work at a company called Theodo. Basically, it's an IT consulting firm, and we love building digital products using open source technologies. You can see on the slide some of the technologies that I work with daily. So a few years ago, this is how my software engineering journey began. I worked on some 2 years old code base, which had a Node.js backend, which exposed a REST API that was consumed by some React clients, and there was a MySQL database as well. So a rather classic and simple architecture. However, we had a big issue with that backend. It was really messy. And that was mainly due to the coupling that was happening in that code base. So maybe you can notice, can visualize some of that coupling in the modules dependency graph on the slide. And that led to some really hard to understand code. It was extremely painful to add a feature. And I was extremely scared each time I would touch some legacy code that was in there because I was scared to break things, and it was easy to break things. And over the years, as I worked on more projects and I grew in my software engineering role, I realized how much the architectural choices can have an impact on the maintainability of the code base. And that naturally led me to wonder what's the best software architecture. So with a bit of research, discussing with some senior colleagues, the online research, I found that the answer is, it depends. Well, it depends because this question is way too broad, way too generic, and it necessarily depends on your context. So going forward, I thought that maybe a more specific question to answer would be, what are some traits of a software architecture that allows to manage complexity as the code base grows? And I think that's maybe an easier question to answer. And arguably, what we're looking for in such a code base, we want it to be easy to add new functionalities, to add tests, especially unit and integration tests. We want it to be easy to troubleshoot and to deploy. We also ideally want it to be resilient. So resilient in the sense that if one part of the system fails, we don't want it to potentially bring down the whole application. So now we'll explore a few architectural designs and see if they tick all the boxes. Our first candidate is the plain monolithic architecture, which only has one constraint. The application should be organized and deployed as a single unit. And as such, it is probably one of the simplest architecture to implement from scratch. However, this can easily become spaghetti code. So although in the beginning, it can feel very convenient and easy, very quickly as the code base grows, it becomes much, much harder to add new functionalities and to add tests. As it is a single, organized and deployed as a single unit, it is still rather easy to troubleshoot and to deploy. However, because of its, by essence, since it's a monolith, it is less resilient than some other options. One way to enhance the raw monolith is to go for a monolithic layered architecture. So we introduced this logical separation of technical layers, which help us achieve a better separation of concerns. We have this presentation layer, business layer, data layer. And once again, although in the beginning it can feel rather clean, and easy to use. As the code base grows, it can once again become really messy. And this is due to the fact that there is nothing that's preventing this horizontal communication in each layer, and especially in the business layer. So we introduced this coupling in this business layer, which can make the code base really hard to work on, especially if it's a big code base. Okay, so how do we solve that? Basically, what we're looking for is to isolate our bounded context. So a bounded context is a core concept in domain-driven design. I don't aim to go too deep into these DDD concepts in this presentation. But basically, the main idea is that let's say you have a rich business, some application with rich business rules and a lot of complexity. One way to make it more manageable is to split it into smaller, more manageable parts, which we will call these bounded contexts. And one way to achieve that in an application is to go for a microservice architecture. So a microservice architecture is a software development approach where an application is built as a collection of small, loosely coupled and independently deployable services, where each service will focus on some specific business function. And as such, it is a kind of distributed system. And I found this really nice definition of distributed systems on APIscene website. And the key element to notice here is that these nodes of your distributed system will communicate through the network. And that leads to a lot of challenges. So in the 1990s, some engineers from Sun Microsystems, which is the ancestor of Oracle, noticed that developers and architects that try to design and implement distributed systems usually would fall into a trap, which they would call the distributed system fallacies. And these distributed system fallacies are hypotheses that we would assume as true, when usually in reality they are not true. Like the network is reliable or it's secure and the bandwidth is, there will be no latency, etc. And if not handled properly, this can lead to a lot of challenges. It can lead to performance issues, it can lead to security issues, to data inconsistency. And that actually makes it really hard to set up a microservice architecture right. And even if you do so, it will definitely help with the resilience of your application. It will make it easier to add new functionality, as it will be, for example, easier to onboard the developer on the code base of one microservice compared to a whole monolithic application. It could make testing easier, since you only need to write unit tests and integration tests from one microservice, but it will make end-to-end tests harder. However, it will add some other challenges, like for troubleshooting. So you really need some really good observability system in case there is an issue or a bug. And as the number of microservices grow, it becomes harder and harder to manage deployments correctly, the versioning of your microservices, etc. So there is this article that Martin Fowler wrote, which is called Monolith First, where he stated that even if you think that at some point your application would justify using a microservice architecture, you should probably start with a monolithic architecture first. Okay, so now we go back to the monolithic architecture. Let's say we want to start a new application. Where do we start? So we start with the hexagonal architecture. So in this hexagonal architecture, it's a kind of monolithic architecture where we want to isolate the domain, the main business logic, from the outside world. We want it to be framework agnostic and unaware of the kind of implementation details that we have. Like, do we use a MySQL database, or are we hosted in S3? So the domain should be completely independent from that. We can interact with this domain through this user interface. In this user interface, we will find things like controllers, maybe there could be scheduled jobs, or maybe we could be listening to some events. And we can trigger what we would call drive-in ports, which I like to call use cases in this domain. And this domain can interact with the outside world through ports, which are interfaces that abstract this outside world. And these interfaces are implemented in the infrastructure layer as adapters. That's what we call adapters. That's where we find the implementation details. So this is a very nice architecture, since it does allow us to isolate this domain logic from the outside world. However, there are still no rules and no control points on this business logic implementation and on the data layer. And what we want is to isolate our bounded context. So let's do that. We can isolate our bounded context in our monolithic application in what I would call modules. So each bounded context would be in its own module, but they can still interact with each other. Each module will have its own representation of business concepts, its own domain model. And let's say a set of user interface domain in infrastructure is what constitutes a model. And all these modules can interact with each other, and they have this shared database schema and tables. So it's in order to organize the modules, cross-module communication, we don't want the domains to be communicating directly with each other. Since we want for one module, we want another module to belong to the outside world. That's why what we can do is for one module to expose what we could call internal endpoints, which are basically functions or classes that can be used in the other module, but on the infrastructure layer. So that this other module, so that we can consider this other module as belonging to the outside world. So that helped us achieve better decoupling of this domain layer belonging to various modules, but we still don't have no control points on the data layer. And one way to achieve better decoupling on this data layer, so we have these various options to choose from. We could either go from the same database server and shared schema in the sense of PostgreSQL, or shared DB in the sense of MySQL. Same database server, different schemas, different database servers, different schemas, or why not even different persistences. So I put some drawings just to illustrate our various options. And basically a schema is a way to logically group database objects like tables and views, etc. And what I would usually go for would be the second option, because this would allow us to somewhat isolate this database object logically without adding too much complexity to our code base, since we still operate in the same database server. However, there are still some elements that needs to be discussed, like should we allow cross-module database transactions? Should we have cross-modules table foreign keys? Should we allow for joins? And once again, it all comes down to trade-offs, but in my own experience, I would usually go for this. I would usually prevent having cross-modules database transactions and table joins, as that would probably be a symptom that there are coupling between your modules, that you should probably review your bounded contexts. However, I find that having this, keeping this cross-modules table foreign keys is a nice and cheap way to provide some level of data consistency across the modules, which would be something that you would typically be harder to achieve in a microservices architecture. Okay, so now we're going. It's getting better since we have even some better decoupling in our data layer. Our final step would be to achieve better resilience, right? Because we didn't talk about resilience yet. And one way to achieve a better resilience in our monolithic architecture is by using event-driven communication. Let's say, for example, in our drawing that this cart module produces more events than the order module can consume. Well, no issue. We can just stack these events in the one event broker, and our order module can consume these events at its own pace. So it's one way to achieve better resilience, but it's also one way to achieve better decoupling. Since now the order, in order for the cards module to to trigger business logic in the order module, we don't need to import this internal endpoints from the order module in the infrastructure of the cards module. So we also achieve a better decoupling of the modules. However, since we introduce this event broker, once again, we communicate through the network, and this we go back to our distributed system fallacies, right? So at the end of the day, it always comes down to trade-offs, right? And you should carefully think of the best option that would suit your project. So this is what I like to call hexagonal modules, right? It's some kind of way to achieve a best of both worlds between the plain monolith and the microservices architecture. And let's say tomorrow you want to isolate or move one of these modules to a microservice. This kind of architecture definitely helps you to do so, since from the beginning, it helps you to decouple all the logic of your module from the rest of the application. So some key takeaways that I would like you to keep from this presentation. First of all, think of the modular monolithic architecture when starting a new project. I would advise to start from the hexagonal architecture, and as you better understand your domain boundaries and the business logic of your application, to slowly move forward these hexagonal modules. And finally, before moving to microservices or introducing network communications, think of the distributed system fallacies. Thank you.